Another component that we can add to frequency tables to help take more away from them is something called a cumulative frequency. And a cumulative frequency tells us the number or percent of observations that are equal to or less than some value. We can calculate them for any variables for which we can put the values in order from least to most. But as we'll see, they're more useful for some variables than others. I'm going to start with a slightly less useful case here, which is this math variable, where for our cumulative frequency, we can see if we think of this variable as being having the categories in order from least amount of hatred of math to most amount of hatred of math, we can interpret those cumulative frequencies as saying the number of students that hate math at this level or less. So for example, we have about 20 students who hate math at a level of I like it, I guess, or less hatred than that. 51 students who hate math at a level of I'm not a fan, but I'll do it if I have to, or less hatred than that. Where cumulative frequencies really come into their own, though, tends to be for these numerical variables, where we might want to know something like how many students have been stopped by the police 2 or fewer times in the past 3 years. And with a quick glance at the table, we can see that out of the 65 people who answered the question, 50 people had been stopped 2 times or fewer in the past 3 years. And we could use any of those cumulative frequencies to answer that question for different numbers. So how many students had 3 or fewer police stops in the past few years? Easy to see that was 61 out of the 65 students. The final thing that we can do with frequency tables here to help us understand our variables, help us communicate information about the variables kind of quickly and easily, is to group frequencies as needed. And with group frequencies or group frequency tables, what we're doing is we're grouping observations into ranges of values, also known as bins, and then creating frequencies for those ranges of values instead of for every specific value that we have in our data set. Typically, group frequency tables are only ever created for interval or ratio level variables, in other words, for numerical variables. Our goal in doing so is going to be the same overall goal that we have for any kind of frequency table, which is to make patterns in the data easier to see at a glance. But in this case, we also have a trade-off that we have to think about. And what we lose when we group frequencies is detail. If you're not showing the frequency for every observation in your data set, you're losing some of the more finely grained detail that you would otherwise be showing in your table. So when we think about group frequency tables, we have to think about whether we want to make a trade-off between how easy the table is to read, how easy it is to understand, and then the amount of detail that we lose. Group frequency tables are useful in some cases. This is another frequency table from the class data showing people's expressed level of trust in police, from 0 being no trust at all to 100 being complete trust. And you can read this frequency table. If you really squint at it, you can kind of get a sense for, maybe the responses that were given. But we start to run into the same problem that we do with the original spreadsheet of data, which is that it's just a whole lot of numbers. And it's really hard to take a look at this table and take anything useful from it at a quick glance. Grouping our frequencies solves that problem. So if I break this trust in police variable up into 5 groups, 20 points each, I can see that now the patterns in the data are a lot more evident at a glance. So grouping the values from 0 to 19, 20 to 39, 40 to 59, 60 to 79, and 80 to 99 allows me to see now that relatively few students gave answers reflecting low levels of trust. Only 2 students had answers between 0 and 19. 8 students had answers between 20 and 39. The most common range that was given here was between 60 and 79, followed by 80 and 99. So at a glance, I can see here that on balance, students in this class tend to have relatively high levels of trust in police. So that's an example where it's useful. Here's an example where it's not. This is the same police stop data that you saw in the last couple slides. And on the last couple slides, this table was not too hard to read. We talked through it. You can see what it means. But if I wanted to, I could create a group frequency table for it. If I did, it might look something like this. So I've grouped these into ranges of 5 stops. I've got 0 to 4, 5 to 9, and 10 to 14. But when I do this, I have a pretty major downside, which is that I've lost a ton of really important detail. And all the variation between 0 and 4 now is collapsed into this single category. And I've lost all that useful detail, where in the table on the left, I can see the exact numbers for 0, 1, 2, 3, and 4. In the table of the right, I just have everybody lumped into the same category. which, by the way, I'd argue that the experience of 4 stops is probably pretty different from the experience of 0 stops, and you just wouldn't want to do that for that reason also. But our main issue here is that we haven't really improved the readability of the table much, because the one we started with was fine, and in doing so, we've lost detail. So should you group frequencies? If your original table is really hard to read, grouping frequencies is probably a good idea. If your original table is pretty easy to read and you'd lose a ton of detail, grouping frequencies is probably a bad idea.